All right, today we're going to go over exponent and polynomials using the division rule. Your homework is worksheet 5, and by the end of the class, you will be able to use the division properties of exponents to evaluate and simplify expressions. So in order to figure out if an exponential expression is simplified, there are a couple of things you want to look for. The first one is there needs to be no negative exponents. The second one, the same base does not appear more than once in a product or quotient. No powers are raised to powers. No products are raised to powers. And then the new one is no quotients are raised to powers. Numerical coefficients in a quotient do not have any common factors other than 1. This means that that fraction part of it cannot be reduced. So for an example, if you were to have 36 over 9, we could reduce that to 4 over 1, which would also equal 4. You also cannot have something like 2 over 10 because those, 10, there we go, because those can also be reduced into 1 over 5. So when we're finding quotients to powers or of powers, so we have a fraction that has powers on top and bottom or one or the other, the first thing that we're going to look at is kind of what's happening with these. And so we're going to go ahead and expand out these expressions. So if I have 3 squared, that's going to be 3 times 3. And then if I have 3 to the 5th power, that's going to be 3 times 3 times 3 times 3 times 3. Well, in a fraction, if we have the same number on top and bottom, we could go ahead and simplify those. So those would simplify and these would simplify. This would leave us with a 1 on the top, and then we would have 3 to the 3rd on the bottom. So 3 squared over 3 to the 5th is the same as 1 over 3 to the 3rd. Okay, so if I'm looking at number 2 here, 5 to the 6th, 1, 2, 3, 4, 5, 6. And then over 5 to the 4th, 1, 2, 3, 4. And then we can go ahead and simplify. This leaves us with 5 squared on top. And then on bottom, we just have a 1. Hopefully this is kind of starting to show you a pattern that's happening when we have a quotient with exponents. The first two had numbers as the basis, so now we're going to go ahead and look to make sure it works as well with letters. So x to the 7th, 1, 2, 3, 4, 5, 6, 7. And then x to the 9th, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then same thing, if there's a x on top and an x on bottom, they can simplify. So these all simplify. And so we're left with a 1 on the top and an x squared on the bottom. So if we go ahead and we take a look at what happened with 1, 2, and 3, hopefully you are seeing a pattern. And that pattern is that if we are dividing the same base, so as long as the base is the same, then we can subtract the exponents. So now there is a typo right here. This is a to the x and then b to the y, but really we're going to change that to a to the y. And so if we had this problem, our answer would become a to the x minus y, the top number minus the bottom number. So if we go ahead and we look at example 1, here they are the same base of 2. So this would become 2 to the 7 minus 2, which is 2 to the 5th. Go ahead and go with the x to the 4 minus 3, which is x to the 1st. And typically we don't write an exponent of 1, so that would just be x. Here we have quite a bit in here. We have the m to the 5th on the bottom with an exponent of 2. So we're going to go ahead and simplify that first. So I'm going to leave my top the same, m to the 5th, n to the 4th. If I have m to the 5th squared, that's going to give me m to the 10th, and then this is an n. We could write in that exponent, so kind of like on number 2 where we took the 1 out. This one here, it may help you to put the 1 in. When we do this, we are going to focus on the m's and the n's. So the m's are going to go together, and then the n's are going to go together, because remember, they have to have the same base. So when we do this, the m to the 5th minus 10, and then the n would be 4 minus 1. Well, if we take 5 minus 10, that's going to make that a negative 5. And then if we take 4 minus 1, that's going to make it a positive 3. Well, we said earlier we're not able to leave something with negative exponents, so we're going to go ahead and get rid of that negative 5 on the m, and hopefully you remember that with a negative exponent, it moves across the fraction bar, so that n to the 3rd is actually going to stay on top where it is, and that m to the 5th is going to move to the bottom and become a positive 5. So n to the 3rd over m to the 5th. Number 4 is a nice one, lots of things here. So the 3's are going to go together, the 2's and the 4's. So if I go ahead, this would become 3 to the 5 minus 4, which is 1. This is going to become times 2 to the 4 minus 2, which is 2. And then times 4 to the 3 minus 6, which is negative 3. So the same thing happens there. We don't like having that negative exponent, so we're going to go ahead and simplify that. So the 3 to the 1st, the 2 squared are going to stay because those have positive exponents. And then we're going to move that 4 to the negative 3rd across the fraction bar and make it a positive. Since we have numbers as bases, we're going to go ahead and actually find these answers. So 3 to the 1st is a 3, 2 squared is a 4, and then 4 to the 3rd, if you use your calculator, that would be a 64. Well, 3 times 4 is 12. So I would get 12 over 64. I am then able to go ahead and reduce that. I could divide those by 4, so I would get 3 over 16 would be my final answer. Now what we're going to have is we're going to have a quotient to a power, so a whole division problem to a power. And ultimately what's going to happen, the rule is if your quotient raised to power each term, each base will get the power. So I'm not a big fan. This isn't quite the right rule, and so we're going to cross that off and we're going to write one down here. So this would be the rule if I have A divided by B, those are both different bases, and I'm going to take this to the n power. It's kind of like the distributive property. We're going to give that n power to both bases. So I would get A over n and then B over n. And then you would look to see if you could simplify. So if we look at problem number 1 here, we're going to go ahead and give that 2. So 4 to the 2nd power, and then the 2 is going to go down to the bottom as well. So 7 to the 2nd. Well, 4 squared is 16 and 7 squared is 49. That can't reduce, so that would be my answer. This one is nice and fun. Remember that this 3d squared is a multiply. So actually this one has 4 different bases because this is also an e times f. So that 4 is going to go to all the bases. So it'd be 3 to the 4th. I'm going to go ahead and put that d squared in parentheses so I know those go together, and that's all going to go to the 4th. Then on bottom, I'm going to have e to the 4th and f to the 4th. So now we need to go ahead and get rid of those parentheses there. While we're doing that, we're also going to go ahead and simplify that 3 to the 4th power using that calculator. I'd get an 81. d squared all to the 4th power would be d to the 8th. And then on the bottom there, none of that can simplify, so we just leave it as e to the 4th, f to the 4th. So we're going to go ahead and do these examples using that rule where we're going to give that outside power to all the bases. So this top one here would become 2 to the 3rd all squared. And then on the bottom, it would be 3 to the square, or 3 squared, sorry, 3 to the 2nd squared as well. So if I go ahead and simplify 2 to the 3rd squared, that would become 2 to the 6th. If I simplify 3 squared squared, that would become 3 to the 4th. I could then use my calculator. 2 to the 6th would be 64. 3 to the 4th would be 81. So my final answer would be 64 over 81. On number 2, I'd have 3 to the negative 3rd over 4 to the negative 3rd. We don't like negative exponents, so what we're going to do is we're going to move the base with the negative exponent across the fraction. Here, both of them are negative, so they both will move. So the 3 to the positive 3 would become the bottom, and the 4 to the positive 3 would be the top. Well, if we use our calculator, 4 to the 3rd is 64. And 3 to the 3rd is 27. 64 over 27. All right. Number 3, I'm going to go ahead and distribute that square. So I'm going to get 2x to the 3rd squared. And then I'm going to go ahead and have xy to the 3rd, all of that squared. From there, it's kind of up to you on how you want to simplify it. I like thinking that this is going to be 2 squared and then x to the 3rd squared over, this would be x to the 3rd, y to the 3rd all squared. So I kind of started with that outside, or the inside, I'm sorry, the inside 3. Well, 2 squared is 4. X to the 3rd squared would be x to the 6th. So my top is 4x to the 6th. And then on the bottom, x to the 3rd squared would be x to the 6th. Y to the 3rd squared would be y to the 6th. We're not solved yet because simplified. We have an x to the 6th on top and an x to 6 on bottom, so those would cancel. So our final answer would be 4 over y to the 6th. Number 4, I'm going to kind of do it a little bit differently than I did 3. See which way you like better. I'm going to go ahead and I'm going to distribute that negative 2 to both of these bases up there. So I'm going to go 2 to the negative 2, and then I'm going to go x squared to the negative 2, and then on the bottom, y to the 3rd to the negative 2. So then if I go ahead and do that, I would get, we're going to leave 2 to the negative 2, x to the negative 4, over y to the negative 6. Now all 3 of these exponents are negative, so they're all going to change locations. So y to the 6 would be on top, 2 to the positive 2, and x to the positive 4. Well, 2 to the positive 2 is 4, so I'd get y to the 6th over 4x to the positive 4.